Welcome to today's lesson. Today we continue with more examples on functions, basically gotten from past paper exam papers. Alright, so I have a first question which I got from the 2018 paper 1, and it was given 4 marks. A had 1, B 1, and C 2 marks, 1, 1, and 2 marks awarded to the 3 questions respectively. So given that f of x is equal to 2x minus 5 and g of x is equal to x plus 3, find f inverse of x as our A. So we have that A, we have to find f inverse of x. So we're talking about the function f of x. So to get the inverse, we first replace f of x with y. We have y is equal to 2x minus 5, then make x the subject of the formula, so meaning we bring the negative 5 this side. We're going to have y plus 5 is equal to 2x. What we want is to have x with a coefficient of 1, so we divide throughout by 2 and this side by 2. That means our x is equal to y plus 5 over 2. After you make x the subject of the formula, you replace x with f inverse of x is equal to, and where there is y, you replace with x plus 5 over 2. You would have found your f inverse of x. B, we have to find our f inverse of negative 10. Just simply means where there is x in our f inverse of x, we put 10. So we're going to have minus 10 plus 5 over 2, and this will simplify to negative 10 plus 5 is negative 5 over 2. So that's our f inverse of x, or you can express it as an improper fraction as negative 2 into 5 is 2, remainder 1 over 2. That will be our f inverse of x, f inverse of negative 10. Then C is a composite function g f of 3. So you always start resolving with the function closest to the number or what you have in the brackets. So the closest to 3 we have f, so we're substituting 3 in the function f. So we're going to have g brackets, our f of x is 2x minus 5. However, we've been given the x in the question as 3. So in the function f of x, we replace 3 where there is x. We're going to have 2 times 3 minus 5. And this is equal to g brackets 2 times 3 is 6 minus 5, which is just g of 1. 6 minus 5 is 1. So now our interest now goes to the function g. So g of x is defined as x plus 3. So what we have is g of 1 is equal to, where there is x we have 1, we're going to have 1 plus 3, and this is equal to 4. You would have gotten the 4 marks awarded to that particular question. Example 2 comes from 2017 past paper 1, and the marks were awarded A with 1 mark, B with 2 marks, and C with 1 mark. So the functions f and g are defined by 2x plus 1 and 5x minus 1 respectively. Find g inverse of x. So we're looking at g inverse of x. So our function is of interest is g. So then we have g of x, that's our A. G of x, we replace g of x with y. We're going to have y is equal to 5x minus 1. Then we work towards making x the subject, the formula. So we leave what as an x this side, we bring the number this side. We're going to have y plus 1 is equal to 5x. We divide both sides by 5 so that we can have x remaining along this side. We're going to have x is equal to y plus 1 over 5. We replace x with g inverse of x is equal to, where there is y, we put x plus 1 over 5. So this is our g inverse of x. Then we find our composite function f g of x. So again, you first resolve what you have closest to what you have in the brackets, which is g. So our first function of interest is g. So we're going to have f of g of x is given by this. So where there's g of x, we put the equation that has been given to us, which is 5x minus 1. So what we have is f of x is equal to 2x plus 1. What we want to find is f of 5x minus 1. Simply means where there is x here, we have this equation. Equally, in the expression of f of x, where there is x, we substitute what we have in the brackets here. That will mean we have this is equal to, it's 2 times x. In this function we have 5x minus 1, so we have 5x minus 1, replacing x, then plus 1. 2 times 5x will give us 10x. 2 times negative 1 will give us minus 2 plus 1. And this will give us 10x minus 1. Having done that, it simply means our f g of x is equal to 10x minus 1. You would have gotten your 2 marks. Then for our final question, which is C, we have to find f g of negative 3. It's the same as what you have in B, f g, except where there is x, you have negative 3. Simply means in this expression which you found for the composite function f of g, you just put negative 3 where there is an x. So f g of negative 3 is equal to 10, where there is x, we have negative 3 minus 1. 10 times negative 3 will give us negative 30 minus 1. Negative 30 minus 1 is simply negative 31. So that will be your function fg of negative 3. Then for our third example, we have given that f of x is this fraction here, and g of x is x minus 1. Find f inverse of x. So we're looking at our function f of x. We replace f of x with y. We're going to have y is equal to 5x plus 4 over 5. We have a fraction here. Let's have over 1 this side. Then we cross multiply. So what we have now is y times 5, which will give us 5y is equal to 5x times 1. It's going to be 5x plus 4 times 1 is 4. So this one multiplies everything. Just in case of a different number besides 1 in a different question, this number multiplies everything up there. So now we make x our subject of the formula. We're going to have 5y. The 4 comes this side. We have minus 4 is equal to 5x. We divide throughout by 5. We're going to have x is equal to 5y minus 4 over 5. Then we've made our x the subject, the formula. Next, we substitute our x with f inverse of x is equal to, we replace y with an x, going to have 5x minus 4 over 5. This as our f inverse of x. Then b, this was a, then b, we're getting f inverse of negative 2. So f inverse of negative 2, we already have an expression for f inverse of x. So all we have to do now is replace 2 where there is x. We're going to have 5 times negative 2 minus 4 over 5, and this will give us 5 times negative 2, it's negative 10, minus 4 over 5. Then we're going to have minus 10 minus 4 is minus 14 over 5. You can have it as a mixed fraction as well. Negative 5 into 14, it's 10, remainder 4. Sorry. 5 into 14, so it's negative here. 5 into 14 is 2, remainder 4 over, just write the 4 properly. So negative 2 and remainder 4 over 5. So this is our f inverse of negative 2. So getting our f g of x, I'll need more space, so allow me to rub. So for f g of x in its simplest form, we're going to have f, our g of x is x minus 1, so we have x minus 1. We have f x minus 1, f of x minus 1. So in the function f of x, where there is x, what we have now is x minus 1. So we're going to have 5, we open our brackets, where there is x, we have x minus 1 plus 4 over 5. So that we can have 5 times x is 5x, 5 times negative 1, it's negative 5, plus 4 over 5. Then we're going to have 5x, negative 5 plus 4, it's negative 1 over 5. So we have that fraction, it's in simplest form, and it means that our f g of x is equal to 5x minus 1 over 5. Thank you.